Hello, how you guys doing today? Yes, I'm excited to be here, and thank you for giving me the opportunity to talk to you guys and tell you about what I do. Um, my name is Ali Guarneros, okay, and I am from Mexico. I, um, I grew up in Mexico City, right here in the center, and when I was about 15 years old, there was an earthquake in Mexico that it was so terrible. That's why the picture is right there. Um, that my mother decided to move from Mexico and immigrated to the United States, and we settled in California. So I don't have any pictures of myself when I was growing up because everything got lost in the transition of coming over here. But I can tell you one thing. When I was very young, my mother used to have these encyclopedias at the house. And after school, I used to come and read them. I really like the pictures on the encyclopedia. And specifically one that had things about the space shuttle. I was around 7 years old. And I really liked it. And I read about who made the space shuttle. And I find out that it was the aerospace engineers. I was very young, innocent, and I thought, I want to be an aerospace engineer. I want to build cool stuff, right? So ever since, I was, thinking that I wanted to be an aerospace engineer. So after my mother moved to California, I went to Abraham Lincoln, which is in San Jose. And then after that, I still need to graduate from there, and I needed to master my language, English. And so instead of going to the university, I went to a community college. And I took classes there until I was able to transfer to the university, San Jose State. When I was in San Jose State, when I transferred there, they told me, what career you want to pursue? And at that time, I was like, well, I don't know what I can actually do. So, I asked, what do you guys have in San Jose State that I can, transfer to have a career? And they said, they told me all the careers. And obviously, the first one that caught my eye was the aerospace engineering department. And I got very excited, and I said, I want to be an aerospace engineer, so I want to study that. So I got my degree there, and when I graduated from there, while I was in school, I actually did a lot of cool things as an aerospace engineer, and one of them was to build a rocket. And actually, you can see it right here. It took me a whole year to build it because you have to design it from scratch. And once we designed it and we put it together, actually these are my classmates. We went to Nevada, to a big desert out there, and we decided to launch it. And it's right there, and we're waiting for the launch. And there it goes, really high up, right? I was very excited. It took a whole year to build the rocket, a whole year. And there it was. We launched it. A few seconds up in there, it came down. And then we had a GPS, so we knew where we were going to be able to find it. And when we launched it, you see the mountains back in there? That's where it landed. And we were getting the beep from there, 8 miles up there. So we ended up going like 2 weekends to look for the rocket over there. And so what ended up happening is that when the rocket launched, instead of going straight up and then come down, it actually went up and then went side. And so the computer on board thought that it was coming down because the altitude was not changing. And so it deployed the nose cone from the body, and the parachutes came out. And it was so fast that it basically ripped the parachutes from the cone. And so the cone floated all the way to those mountains back there, but the body came down straight down, and we just don't know where it landed. We were able to recover the cone, but not the body. So that was a learning lesson for me, and it was very exciting. And then the other project that I was involved at college was building this rover. We were designing something that was small that we can actually take to Antarctica and give it to the scientists over there, because in Antarctica it's so cold that people can only go out certain times outside. They're mainly, they have to stay inside. So a lot of times they want to do science, and they cannot go outside. So it will be cool to give them a rover that they can take, and send them out to do some science, or bring the science, to them, and then they can do the science inside. Okay. So, anyways, so when I graduated from San Jose State, my professor told me, there's an opportunity for you to go and have an internship at NASA. And he encouraged me to apply, and so I did. And, this is my first interaction with real, aerospace engineering. So, I graduated from aerospace, but I didn't know what I was going to do, right? So, my job relates a lot to the space station. And I want to show you here, this is the space station. You guys know how big the space station is? Yeah. How big?
It's about the size of 2 or 3 football fields.
No, quite yet. But you almost there. Anybody else has a number? How big?
Square mile?
Not that, not really. A little bit more. Yes.
About the size of 2 football fields?
No, not the size of 2 football fields. Yes.
I think it's the size of 1.
That's right, the size of 1. So you guys actually can see it right here. The size of 1 football field, okay?
Exactly where I got it.
Yes, that's right. Do you guys know how many people live in the space station at all times? Who?
10?
Not 10. Yes, honey.
20?
20? No, that's too many.
Oh, I think 6, actually.
Yes. 15 is too many. Yes. 7. That is borderline. Oops, I'm sorry. Let me just get somebody from here. Yes.
I'd say maybe 15.
That's too many. Yes.
8?
Yes. No, that's too many. 8 is too many. Okay, somebody from the back. Okay, that's too many, but let me just. Yes. Yes. 5? No, not quite yet. Yes. 6. That's the answer. It's right there. There's 6 astronauts, okay? And so, to get 6 astronauts in the space station, we have to use a special vehicle, because before we used to have the shuttle, but not longer, right? So we use the Soyuz, which you can barely see here, but they go in sets of 3. They go 3 up and 3 come down. And they have a special chair that is molded to their body, because when they go there, they're sit down really tight, and they cannot, it cannot be changed, okay? The other thing that I want to talk about this picture right here is that every time an astronauts go up there, they have an emblem sticker. And that sticker represents their flags right there. And it has a number. And it has their names around. And you guys see all these flags over here? That's all the experiments they're going to do while they're in space from these different countries. Okay? I was lucky enough that one of my experiments was part of their mission over there. Actually, Aki, the astronaut, was the one that helped with one of the experiments that I will show you about it. And then I also help with the spheres, and I'll talk about it a little bit more. And a lot of things that I do, it's about deploying CubeSats, spacecrafts, and I'll tell you guys about it. And then talking about the space station, do you guys know how many times it goes around the Earth in one day? Raise your hands. Yes. It is not enough. A little bit longer than 4. Yes.
4.5?
No, more than 4.5.
5?
No, more than 5. Yes. Pardon me?
400?
400? No, that's too many. In one day, how many times do you think the space station goes around the Earth? How many times it orbits? Ah,
Is it 10?
quiet, quiet, quiet. Okay, let me get somebody else that I have not given me answer. Yes? 8? No, that's too few. So, yes. 10? No, that's too few. 30? No, that's too many. Yes, honey. 11? Almost close.
12?
No, almost close. No, that's too many. Yes. Pardon me? 12.5? No, that's too few. Still, let me try to get somebody from over here. Yes. 10? No, that's not enough. A little bit more than 10. Okay? Yes, honey. 15? Very close. Very close. Yes. 16. Yes. It goes around 16 times in one day. That means the astronauts see the sun. Yes, once every 90 minutes. That's correct. That is the right answer. They don't have 16 days. They have one day, but they just go over around the Earth 16 times. And that is the fun. Yes. Okay. So working at NASA has given me the opportunity to meet really cool people, right? I met the astronauts, the last two that went into the space shuttle, right? And I also travel. They send me to places to give talks and tell them about what I do. And I also work with fabulous groups of students and other professional engineers. And I go to conferences to talk about what I do. Yes, honey?
Have you worked with the person who came back not too long ago from Mars?
From Mars? Nobody has gone to Mars.
Yeah. Someone's gone to Mars for 2 years.
No, nobody has gone to Mars. We have astronauts that have been in space for a year. Yeah. Not there yet. Okay, so the other thing that I want to tell you is, while I was working at NASA, one of the cool things is that I work with these 3 spheres, right? And I'm going to play a video for you guys. Hopefully it plays. Oh, there it goes. How can I? You see that? That's Luke Skywalker, right? And he's playing with the spheres right there. You guys see that? So that is where the concept came when MIT was developing the spheres. How can I get out? All right? These little things, oops. These little things right here, right? The spheres. And there are 3 spheres that are the size of a basketball, right? And they float in space, and we do science with, right? So when the first time they came out, they were just like these. Oh my God. Yeah. They were just like this, right? You let them be, and they have this algorithm, and they're dancing, right? And then this one right here is going to jump in, and they're going to do this synchronization, right? So that was the concept about it. Develop software, right? Software that we can actually use for spacecraft. Oh my gosh. Oh. Right. Okay. That we can develop for spacecraft when they're outside, And then the other thing that we did is we developed also software, and we use a smartphone, right? So we put it right here attached to the spacecraft, these spheres, and there's surveillance the area right there. And these are different places that they have to stop. So they're like goals that they have to reach. And right here we can see the program, right? So the astronaut actually is just making sure that the spacecraft, floats and meets all those different stops. He has the software right here. And he's the one that loads that information into the spheres and the smartphone, and then just lets it go, right? So while all this is happening in the space station, a lot of times we're right here at NASA Ames, watching them perform the experiment. And if the astronaut has a question or something goes wrong, he can call down to Earth and say, I have a question. Or, this thing happened, help me. And we're there to help him and answer all the questions he has, right? So now, the other projects that I do is with small spacecrafts, right? Do you guys know what a small spacecraft is? Yes? And the spacecraft that's small, did you have a sticker? Did I give you a sticker already?
Yeah, I have
Okay.
a sticker, but I'll take two.
No, one. Yes, honey.
It's a spacecraft that doesn't hold passengers, but like a rover.
You can consider that, yes, but it's a tiny one, right? And actually, I have it right here. This one is a small spacecraft. And I will pass it to you guys. And just to give you a concept, this is a 1.5 unit. Because one unit is 10 by 10 centimeters. This one is 10 by 10 by 15 centimeters. So it's 1.5 units, okay? So I'm going to start here, and you guys pass it around. You can actually pull that out. This comes out. Okay, so hold it. And that is the other, other things that I do. So I started with the TechEd side, and this stands for Technological Education Satellite, okay? So the first one we did, it was actually an opportunity that we got from NASA. The Japanese were developing this deployer that was coming, they want to deploy things from the space station. And they had an opportunity to have something, and they asked NASA Ames to say, hey, do you have a spacecraft that you can let us have so we can deploy it? And so we built this spacecraft, and and it was just 1 unit because we didn't know exactly how it's going to happen, and we only have 9 months to put it together and make it, certify it, and go through all the testing to make it actually be safe to be inside the space station with the astronauts. So what I'm showing you right here is a video of after being checked by. We put it in a bell jar. We took all the air, and then we just waiting for it to turn on because it had to be turned on after 40 minutes. And then there it goes. The antenna popped out, so we knew it worked after being put in the oven, at high temperatures, cold temperatures, and then vibrate it really hard, right? And then the other video is about when we put it in the deployer, the Japanese deployer. They were afraid that if we have it in the space station out there, it would get stuck. So we had to actually make sure that it wouldn't get stuck even in the worst condition, which is with the antennas being deployed. So right here, this is an Ali switch. It has my name because I came up with the idea. So it was something that after we built the spacecraft, the Japanese were nervous about having us being in the space station and turn on. So they asked us to put a switch, an extra switch so it wouldn't turn on. So I came out with the idea to put this switch in the middle of the CubeSat, and my friends that work with me, they said, wow, let's put it Ali switch. And it stands for Auxiliary Lateral Inhibit Switch. But now all the CubeSats that go into the space station have an Ali switch. Anyways, so what happened after we got to the space station, right? So we had Aki, the astronaut. He was the one who integrated us into the deployer. That was the Japanese launcher. And, they shoot us down. And these are pictures from the space station, real pictures. And while all this was happening up in space, we were here in NASA Ames trying to listen to the spacecraft to make sure it worked, right? Because it had a radio. And after a few hours, we started getting these packets, from the Japanese and from Germany and from other people from around the world, sending us the package, and we knew it was alive. So the spacecraft actually lived for about 7 months, and it re-entered the atmosphere and burned. And it was very successful. We actually learned how to put things into the space station and then shoot them down, right? So the next thing I was part of, it was this little experiment. And it was basically trying to develop a different system of communication for small spacecrafts. Because if you think when a spacecraft comes from space, from the rocket, it goes really fast around the Earth, right? So you actually need to know where it's coming and be with a giant antenna outside and trying to make sure that you're aiming at it. Because if you don't know the time and the angle, and if you miss it, then you're not going to be able to get the information that you want from the spacecraft. So we were trying to make some other ways to do it. And this way was to develop an iridium. We use an iridium modem to communicate, right? And it deployed, and it worked only for 24 hours, and it was successful. And then the next time we did another one was a 3-unit CubeSat. So it's twice the size of the one that we have here. And it had an exobrake. An exobrake is like a parachute, but it's a cross parachute. And it's basically giving us the opportunity to increase our area and actually deorbit fast. And so we developed it, we put it in space, we went against to the Japanese module, and this time Mike, the astronaut, was the one who integrated us. We're right here, and we got deployed. We were in orbit for 4 months, and we re-entry, and we were successful. And then the next one I did, it was another one similar to that one, but this time we had a GPS, we have an iridium, and we also have a exobrake that instead of having 4 rigid struts, it had 2 rigid struts and 1 flexible, okay? And we deploy it, and it survived, for 4 months, and then re-entry, and we got a lot of data about it, right? And then the next experiment that I did was this one. This one is very fun. I'm going to play this video while I'm talking. So I was part of this group of engineers. It was a suborbital rocket. A suborbital rocket doesn't go all the way out to space, but it actually goes to a certain altitude. In this case, it was 350 kilometers, and it comes down. And you can do a lot of experiments. In this case, we were developing this huge exobrake, which you can see here with these engineers are building. It was 4 meters by 4 meters long, okay? And I was part of the engineers that I was in charge of integrating the stack. That's what we call it. Basically, all the, computers, the boards, the cameras, attached to this thing, right? And you can see how it was developed, built together and tested, this video right here, the huge exobrake. And once it was, this part right here was actually in the bottom of the payload right here, and the exobrake was on top. And right here you can see the video where the rocket is sitting on the launch pad right here, and we have a camera from the nose cone, and we have another camera here that is this camera right here. We have actually 2. We have one facing one side and the other one the other side, right? And there's us. And so I was there when it was being, get ready to launch. Let me just forward this video. Okay, there we go. So you can see how the camera is looking down at the rocket. And this right here is the inside of the cone. And you can see the heating, and you can also see right here the path, because we're looking at the rocket, right? So the idea was that when it reached, a really high altitude, the exobrake was going to be deployed from the rocket, right? The cone was going to be ejected, and then the exobrake, actually we call it thorax payload that had the exobrake, was going to come out, right, with the exobrake and expand. And we were going to be able to see how the exobrake was going to, expand and have beautiful pictures, right? But guess what? It didn't really happen that way. There's always, okay. So right here, this is when it's reaching the atmosphere, And you can see there's actually the inside of the camera looking. And that's when we noticed that, because we didn't know if we were already out or not, right? So when we saw the camera here turning on and looking at the plate, we thought we knew we were inside. We were still inside, even though this was already looking, it had reached the top of the apogee and it was coming down. So we knew we never were ejected, as we thought. But then suddenly, you can actually see right here, something was coming out. Because remember, the main idea and focus was for us to do the exobrake, right? So there it comes out. And we're like, yes, we're coming out. And then this camera right here, that you see here, you're going to see very soon. You can see how it's coming out, and you can see the Earth. 350 kilometers in altitude. And it was beautiful. But then something happened. While we were up there, we never really got deployed. We got stuck to the rocket. So eventually what happened is that we ended up coming back inside. But we learned a lot, because this camera was actually using a Wi-Fi frequency. Basically, it's the same Wi-Fi that you use for your phone, in your house. So think about it. If you can build CubeSats that I can actually use the Wi-Fi and actually get really cool video and data, it will be very easy for us to develop technology. Okay, so the next time we were able to do something similar, not as hard and laborious as the exobrake, was we built the Thorax 9. And right here was a small component of the previous experiment that we did. And right here you can actually see myself, building this thing right here, which is a USB. And this is the main payload, the exobrake. And it had the camera, it had the iridium, and it had some boards, it had the Wi-Fi, and these were the batteries, and we have to have switches. And this is the rocket, right? And it was amazing as the other one, right? Because we were able to get data from it. Really cool. And let me show you right here. Okay, gonna go to this one. So there's a rocket. Exactly at 2. Okay, there it goes. Goes high up. There were 4 different experiments in this rocket, but we were one. We actually used one of the belts, the rings, and we just placed our, payload in there, and we had a camera facing, actually 2 cameras facing outside. And then right here, we were in mission control, and we were waiting to see the picture. This rocket only reached 180 kilometers in altitude, and it came down, right? So there it goes, and I'm just waiting for. Okay, so there it is. So we lost the video of the feed from the rocket, but now we actually looking at what the rocket, the payload inside, was looking at. And so we have these cameras running, and then we're looking at the video where we can see some of the really nice pictures of the Earth at that altitude. You guys see that? Right here. And it's very blurry, because obviously we're going really fast, and it's really hard to actually we have a big dish out there. It's like, 2-meter dish that is trying to, trace the rocket that is going really fast and down, get the data so we can get all these amazing pictures of the Earth. There you go. And it was, a success. It only lasted about 50 minutes, and it came. And we were able to get it back. This time, this rocket was able to get, we were able to get it back and look at our payload. Obviously, it doesn't work anymore because it got into the ocean. We have to rinse it. But, where are we going with all these experiments? Where are we actually going, right? And the first thing that I can tell you is that right now, going to the space station, we have to have these huge rockets, right? Every time we want to go up up to the space station, send science, send astronauts. We have to go to these huge rockets. And if we want anything from the space station, we have to use the same modules to come down. And it's very expensive. So we thought that it would be very inexpensive if we build something that we can shoot up from the space station. And it doesn't have to be traced. No humans have to be, controlling it. It can just come down, and we can actually retrieve it. So this is where the Isaac sample return is. And so all of our CubeSats that we're building has this technology where we have the exobrake, and we're trying to understand how to guide the spacecraft, right? And then how to re-entry and not burn, and then how to actually guide it to land somewhere here on Earth. So if you can imagine how much science you can do. And then the next step will be that once we master these, we can actually go to Mars, right? And put rovers in there. And then the next other project that I actually worked, it was the small spacecraft, actually the one that you guys are looking at right there. This is actually the nodes, we call it nodes. And it was a cross communication. We actually deployed 2 CubeSats from the space station. And we're trying to do communication with science. And actually, I have a video right here, that they were deploying May 16 at 7 a.m. And we have the 2 spacecraft coming down, right? And that was it. But we also have really good pictures. And these are pictures, actually, from the deployment, and you can see how the spacecraft comes down, right? And there is, you can barely see it right there. And they're up there, and they're doing science. And then I have this advice, because I'm almost done out of my presentation. So, working and, being an immigrant and, doing all these things, my advice to you, if you want to reach anything, is that you have to set your goals, long and short, because a lot of times you want to reach a goal and it's too far away from you, and it takes a lot of time, right? So to make sure that you guys reach that goal is to make short goals that you can reach right away, right? And also that lead to the long-term goal, right? The next one is to be persistent and don't give up. A lot of times I build rockets, I build experiments, and they don't work this, really good. But at least I'm learning, and the next time I try it, it's going to be successful, right? Then if you guys dream big and learn from your mistakes, you will become masters of, whatever expertise you guys have. Don't be afraid. A lot of times I question myself a lot, when I'm building these things, would it work? Would it be successful? But, I learn a lot from my mistakes, so I know that next time, something happens, most likely I will know what went wrong. And obviously, educate yourself a lot. Always hope for the best. You just never know what's going to happen. And then the last quote is that you cannot change your past, right? But you can change your future by preparing yourself today. And, really think of where you want to go and, in your life, and make sure that you reach it by preparing yourself today, okay? And do you guys have any questions? I think I'm done with my presentation. But do you guys have any questions? Yes.
Do you make parts of the space station, or
Mm-hmm.
wait? So you don't make parts of the space station, or what materials are resistant to the in space? Do you use plastic or foil or something?
Yes, that's very important. Actually, do you have a sticker? You already got one. Okay. So I don't build anything in the space station, like inside the space station, but I build experiments for the space station. And materials are very important, because you don't want to bring a material that it will harm the astronaut, right? So we do use Velcro. I don't know if you guys saw on the, in some of the stuff. We use a lot of these. to help the astronauts, because if you guys think of being in space, the astronauts they cannot hold to anything. You know, they're floating, right? So a lot of times when we're helping the astronauts, they let go of something. Obviously, here on Earth, it goes down to the floor. But in space, it just floats away, right? And if they cannot catch it right away, it goes and they can lose it, right? So a lot of times we use Velcro. They use actually Velcro to strap things down and put it attached to something. Or they use a tape, Kapton tape and things like that. Yes.
What inspires you to keep working at NASA?
What did inspire me to keep working at NASA? I like actually the stuff that I do. Every project that I do there's something new. It's never the same thing. There's always changing, and the cool thing is that I have an idea or somebody has an idea, and we work together to put it together to make it work and understand if that idea actually works. And that is the fun thing. It's always something new. It's never the same thing. And it's very flexible. I do a lot of things. And I also teach. I come to talk. And so it's flexible. Yeah.
A question.
Yes.
Is it hard to work at NASA?
What was the question?
Hard.
Hard to work at NASA. That's a good question. I'm sorry. Is it hard to work at NASA? You have a sticker? Okay. So it is not hard to work at NASA because it's fun, It is always something new. It never changes, And I either build something or help somebody to build something. And I either learn. I'm constantly a learner. I learn new things every time I'm there at NASA and working with other scientists. And there's people who learn from me, right? So it's fun. Yes.
Wait, what are rockets made of? Like, what type of metal?
We actually use aluminum, right? There's chunks of aluminums, and they get, we have engineers that actually grind them and make, the rings and the cones and everything. Okay?
We have a question back here, please.
Yes.
What project took you the longest?
Pardon me?
What project took you the longest?
What project took the longest? Working at NASA, right?
Yeah.
That's a good question. Maybe the Sorax 8. It took about a year almost. Most of the other projects are like very short, few months, 6 to 9 months, and they're done, and then I can continue to the next thing. But if you look at it, all the projects that I'm doing that they're really tiny, they are for a very long project, which is going to Mars.
All right, we've got another question here.
Yes.
Do you ever want to go to space, like with NASA?
Did I ever wanted to go to space?
Yeah.
I do, all the time. It's cool. I get to see the astronauts go and, and play, and I'm like, why am I not there? So yes.
We have a question in the back row, back here.
Sure.
What are the suits made of?
What are the suits made of? Oh, that is so interesting. That's a really good question, okay? I brought a spacesuit so you guys can see it and try it on. Obviously, it's not the real one. But the spacesuits that we have right now in space, they have layers of material. And it's a system, if you think about it, that protects the space. It's like a spacesuit, like spacecraft that you put on and you can actually walk out from the space station. So it's your personal space craft. And they do have, a very special material to resist the radiation, but also they use another layer where, they have water, so they can be cooled or, they can maintain a really nice, comfortable temperature, right? And because if you think about it, they have to wear the spacesuit for about 8 or 10 hours. So they cannot go anywhere. They have to be in the spacesuit. Once they put it on, they have to be there for a very long time. So a lot of times they have to have water, not only to control the temperature, but also to drink, right? And this one has a clear shell, but also the spacecraft that the astronauts use, they have like two different ones. One, to see, but there's another one for radiation. So that one is not a real one, but it's a very complex space suit.
Thank you. We have another question here.
Why does NASA want to make those weird sphere thingies? Those one that.
Oh, the spheres?
Yeah, I mean they clearly are not for lightsaber training, so.
Yeah, that's for sure. Yeah, we wanted to be. Actually, they were an MIT project that became a NASA project. So MIT developed them, and then they pass it on to NASA, and then NASA now uses them as a test development. So we can test different hardware or software inside the space station. Because if you think about it, when we develop things that go into space, we have no environment that we can actually test it. We can only assume that actually will work in space. So having the space station and having some kind of hardware that we can attach to and do experiments, it gives us an idea. So that was the reason why the spheres.
Thank you. We have time for just a few more questions. So there's one at the back, and then we'll come here.
Yeah.
Are you working on any project right now?
Am I working in any project? Yes, actually, I didn't talk about it, but I'm actually building another, we actually finished building another spacecraft, which now has a guided exobrake. And then we're working on the following one, which might have propulsion, right? So there's always work coming in now. Yes?
What project are you most proud of?
What project I'm most proud of? All of them. Every single one, is a success for me.
All right,
I learned something new.
Sorry. Another question here?
All right. So, what do you exactly plan on doing in the future? Do you plan to continue your job, or do you plan on moving on a different field of work? And if you do continue your job, what do you plan on doing?
That is a good question. I do love my job. The only reason I haven't left NASA is because I really love what I'm doing. I do not picture myself anywhere else. When I graduated from school, that's the only work I ever got to do, and I really loved it. I constantly do different things, and I interact with a lot of different people from different countries, different agencies, the Japanese, the French, so it's very interesting. So I don't know. I mean, I might do something later on, but right now I really love what I'm doing.
I think there's one more question back here.
Yes.
What training do the astronauts have to go through in order to go to space?
What training? There's a lot of training. I'm sorry, honey. So the astronauts, once they get selected, it's about 2 to 5 years of training. And basically, they have to learn everything, the whole system in the space station, because if something goes wrong, they know exactly what to do. The other one, they have to actually also learn how to scuba dive, because when they put these spacesuits, even though, this one right here is very light, it is a very heavy spacesuit, and it's about 300 pounds or so, or more. So humans cannot actually hold that weight. So what they do is that they put the astronauts in the spacesuit, and with a crane, they put them down in water, and they have this huge mock-up, a buoyancy lab in Texas, where the space station is underwater. And that's the mock-up that they go. So they drop them down there, and then they have to do operations underwater with the whole spacesuit, and then do the drills. If there's something goes wrong, how they're going to do it. So they have to get trained on that. And they have to have the physique, and the stamina to do it, right? Because it's very, very tiring. Like I said, if you are in the spacesuit, it's like 8 to 10 hours in the spacesuit. You cannot go even to the bathroom. You have to stay in that thing for a very long time.
All right.
So, and then they have to do computers and all this other stuff.
It's very
programs.
complex.
Yeah.
We have another question over here from one of our instructors.
Yes.
So besides the spheres, have there been any solutions that were inspired by science fiction that you guys, you know what I mean?
That's a good question. Any solutions? You know, that, to tell you the truth, I cannot think of one right now. But that one definitely was like a MIT project that they wanted to build spheres just like the one from the movie. And they just, you know, develop it, and we help it put it in space. So that was very cool. So I can think of anything besides that. Yes.
When you guys work on your projects, do you guys argue about ideas?
That's actually a really good question, because guess what? I am usually the only woman in a whole group of men's, right? And it is really hard, you know, when you're building something and you have to convey your point. We have conversations and arguments about it, but they're all good conversations. And we discuss a lot, and we come with different reasons why we have to go a certain way or the other one. And it had helped me, myself, a lot, because, you know, working with a lot of boys around me, you know, I have to be very strong. And, you know, tell them this is my point, and I cannot, you know, unless there's an opinion that differs, you know, I will stand on my, you know, my judgment, right?
Okay, we have so many more questions, and I'd love to get to them all, but I don't think we can. So we're going to take just a couple more, and then our amazing rock star is going to stick around and hang out with us, and you'll be able to chat with her and get a picture taken with her and ask her for her autograph in a little bit. Okay? So I'm just going to have time for a couple more questions. All right. So we have just a couple questions here. So we'll start here.
Who sponsors NASA?
Who sponsors NASA? That's a good question. NASA is being sponsored by the government, by your taxes. Well, not really your parents' taxes. Actually, just to give you a pointer, for every penny that we get from taxes, we get half. No, but actually, for $100, half of 1 penny is what we get. That's more, yes.
All right. We can look up more research about that later. You can go home and find that out. All right, you ready?
What grabbed your interest in joining NASA?
How did I get interested in NASA?
Yeah.
Actually, I never thought about joining NASA until my professor actually told me, Ali, you know, go and apply for this internship. Because I never pictured myself working for NASA. Yeah.
All right. And I know that we have a few more questions. You had one more question?
What's the longest time someone's been in space?
The longest time, what?
Someone's been in space?
But we just had 2 astronauts who were there in the space station for a whole year. And that's one of the longest times that a human has been in space, constantly. Yes.
All right. And one last question here.
Since the spatial missions have been discontinued and you're funding SpaceX, when do you stop to try to stop funding them and have your next project ready to take humans to space?
That is a good question. Actually, we are working already in Orion. I didn't put it over there, but I was part of that concept. It's basically, we're building not a space shuttle, but a module that we can actually take humans into Mars. Yes. So we're actually building it already, and we've been doing testings. And it's been actually built in another center, not here, but here at NASA Ames, we test the thermal protection system, which I was part of. But we are working on it.
All right. At this point, I think we do need to wrap up, but I know that you've still got great questions, and so don't worry. Ali's going to be here. She's happy to answer more questions, and she's going to hang out with us for a little bit longer today. So just as we wrap up, as we close today, if you can share just a couple words of wisdom and advice, what would your advice be for these students who are obviously so excited and interested in all the work you're doing and here to take on new challenges today?
But my advice for you guys is that, like I said, you know, we cannot change, the past. The past is in the past. But we can actually change your future, and we can do it by preparing ourselves today, right? And that's exactly what you guys are doing. You guys are preparing yourself today by learning, computer programmings and doing different things in science and technology, and that's really cool. I never had that opportunity, but you guys do, and I know you guys are going to be able to do cool things.
Perfect. Thank you so much. And let's give a huge round of applause for an incredible rock star. Thank you so much, Ali.
You're welcome.